on our Athens series of academic dialogues, and today we are going to have a discussion about STEAM education, and we're going to have four presenters. And now we'd like to announce the first one, Professor Bala Maheshwaran at the Northeastern University in USA, and he's going to talk about STEAM education through experiential learning.
I will explain that part. They gave me this title, I put that title, I am going to spend time here, right? Actually, I am part of some organization. We organize a lot of conferences and panel discussion on these topics, STEAM education. Actually, last time at the ASW, we organized one. Actually, that's where we picked this title. So I will spend a little time here. I think our time is kind of limited. So this morning you saw a lot of equation, a lot of writing and a lot of things. I don't want to show slides with writing, just only pictures to make things a little different. Before that, I am from Northeastern University. It's a urban university, a little advertisement for my university. And it has a lot of interesting program there. We have over 20,000, 25,000 undergraduate students, about 8,000 graduate students. That means a pretty big one. Pretty big university. That's actually, this is part of College of Engineering, right? And we are pretty well known, inviting famous people. That's President Kennedy, Bill Clinton, Colin Powell. This is our graduation, and this is our standard graduation. This is a mediocre size graduation, right? Last year is much larger than this one. You can see it's a Boston Garden where all these Celtics and others play games. So I'm here, actually this is not my main part here. Simply I'm saying, okay, STEM with plus A, arts, right? Now he gave different definition this morning for arts, but I am saying just arts, right? Together it's STEAM, right? So it's a general belief that innovation is an iteration of creativity and critical thinking. That's not my statement, it's from the literature. You can see that. So the innovation is the key nowadays for most of the activity, design and industrial changes. So the innovation, they believe that happens with making things better for small kids at young age. Arts is actually kind of contribute big time for the innovation part. Then you can easily add up that one for the science. So simply you can integrate the innovation, whatever thinking ability gained from arts, and you can use that for science. Arts you can give different type of definition, right? So this is just a standard thing from literature, and also we are saying that these are kind of a avatar, whatever of human creativity, but let me get into this part. There are places at USA, nowadays they are trying to integrate arts activities in order to, improve STEM education. So these are at high school level. But I am from college, I am going to say some experiential activity here. And of course, this is a statement simply I want to make arts more a part of our culture, right? Now, this is the one I am going to talk about. What I did last summer for this interactive and experiential learning, right? So we took about 16 students to Silicon Valley. Silicon Valley, we stayed there in a hotel for about 5-6 weeks. And we went to several companies. We had seminars. We have what do you call the company visits and activities, project, presentation, all kind of things. This is part of two courses. One is called Customer-Driven Technical Innovation. The other one is called Product Prototyping. So simply, they have to deal with customers, they have to interact with people, they have to get the experience, they have to come up with their proposal, then they have to use some high-tech IoT, Internet of Things, and 3D printing, things like that, to come up with prototype. So the companies we went last time is simply, Intel is a big company. I don't want to go here in detail. And you can see Tesla, AMD, Nvidia. It's not easy to get appointment there, but we managed to get. And also you have to have personal connection in order to get in. It's not automatic, simply they'll say hello, come. So you have to deal with them. Of course, he is from San Jose. He knows there are other interesting learning places like Tech Museum, MakeCafe, a little away from that one, Intel Museum, Apple Center, Stanford University. Is a highly, very sophisticated area for these type of things. And we went to so many other social activities. Means interactive and experiential learning. We need a very close interaction in chemistry for our students. That's what we did. And we have speakers, a lot of speakers. We stayed there only for 4 to 5 weeks. Imagine we had 20 people presented their work. Some are fellows from industry. Fellows mean pretty high position there. Some are managers, CEOs and things like that. And also students, they have to give presentations. It's not just going there sitting and watching others' presentation. They have to learn, they have to study, they have to come up with a proposal, presentation, all kind of things. Not only that, they have to make things. Right? Product. They have to come up with something. So that's what we did. At this point, there are so many activities, guys. All these happen in 4.5 weeks, technically, including. So that's really a very short time for a lot of these activities, in addition to my boring lectures. Right? So, and there were other things we did after San Jose or Silicon Valley. We moved to San Francisco. We spent some time there. We did some work. The students stayed in this hotel. You can see there's a nice pool there, and they spend time there. Sometimes they take hot bath and sit and talk and discuss issues. This is kind of a very interesting environment, right? And naturally, San Jose is a very beautiful area. Just to show you how attractive is the area, you walk there, you will see some friendly creatures there, trees and flowers and things like that. At this point, I want to show you some other key places that we went. You can see this is our campus. We have a mini campus there in Silicon Valley. That's a northeastern campus. And we went to Intel. We went to Tesla, inside the Tesla actually. And we went to AMD. Managers, fellows, they gave presentation there about the latest GPU. You know, it's actually, they were very supportive. And Google, he's actually an engineer there. He gave presentation and they took us and show the places and things like that. And this is NVIDIA. It's another famous, you know, company. They make GPU. Not only that, we went to so many other places. This is, we call it a VMware. And this is, that's another place I need to, and this is HP. So this is actually, he's a fellow at HP. He gave from Arizona to give a talk for us. And this is Action Port. So there are so many places we went. These are all different companies, different. But students didn't actually go there. Also, we went and we enjoyed. You believe that?
You have to.
Yes, can you see me there? I am doing better than students, actually. That is Tesla, guys. That is Tesla is a really huge.
Looks like you're on cloud 10.
These are the talks I am talking about. This is a fellow from HP. This is a CEO of a company, IDT. This is the dean of Silicon Valley campus. This is a manager from, you know. These are people you have to make personal connection in order to get, you know, whatever. I have to show you the projects too that we did, and I'm hoping she will give more time. Right? These all are managers and engineers and CEOs. They gave talks in different topics. Sometimes about business, how to start a company and things like that. Sometimes they talk about, you know, IoT. Sometimes they talk about, you know, what's the future. This is the Intel presentation. Things like that. These are some startup companies. So we have a flavor. This is actually State Farm. It's an insurance company, but they do a lot of innovation activity. You can see our students, they sit and listen. Now I'm getting into student side. You can see when they talk, they listen. When he talks, they listen. They sit and pay attention, take notes, and things like that. It's more interactive. They have to talk to each other, interviewing people, right? Come up with the idea to make a product. Some students, sometimes they take notes or they play with their cell phone too.
Why not?
That's happened all the time.
That's IoT.
Yeah, that's what they say. Oh, I'm using my cell phone to take notes. That's fine. Right? This I'm going to move a little faster at this point. This is actually this Intel. You know, they use their whatever thing. This is VMware. So they play with their latest invention, things like that. This is actually the fellow from HP talking about their one of their large whatever chips there, and student they have their own interaction. So let me keep moving, and I want to move a little fast here to show you some of the. I'm going to skip the social event because we don't have time, but we did a lot of social activity too because we need fun, because we need to interact in a friendly manner, right? You can't always. So this is the Santa Cruz. I'm sure he's familiar with this part. That is the Great American, and the kids are, you know, at the beaches and, you know, amusement park and things like that. They had this angel, there's a fun with bicycle, play games, all kind of things. It's a very friendly environment, right? And social dinners. There's money involved in all these things. You can say, let me keep moving, and learning activities. So we didn't stay there and, you know, move around and things like that. We did a lot of work there in addition. This is the logic I use, right? I asked students, you all are good kids, smart kids. Don't ask me what to do. You come up with the project. You paid attention, you interview people, you did so many things. You tell me what you want to do. Then I will give the comments and corrections and changes. That's what so they, as a group, they get together, work and take notes and, you know, record things. I played with this one. We did different activities, rotating teams, fixed teams, things like that. For the final project, there's one team work. For the other project, I rotate them to get more interactive, you know, environment. So you can see their focus, they work on different issues as a group, teams. Highly we use sensors, 3D printing, and things like that. Also, there are places, you know, these are different groups. They have a different interaction there. Interaction is not only with this group, always, then I change the groups for different projects. Finally, this is a very starting project. I asked them to design something using paper, cardboard. Just a Silicon Valley product. So this is somebody who designed Google Glass. That's not the key part. They have to give a presentation about all the detail, function, the way we work and current business situation, whether it's a successful product for Google or failure, things like that. It's not just making things. We have to talk about those things. Also, we did some standard reverse. I asked them to pick Silicon Valley product to do reverse engineering prototype, but they pick some, you know, standard things. But they have to study, they have to open using makerspace. They have to study everything in detail, put things back together, then give a presentation. Not only that, we ask them rapid prototyping. Normally the word rapid prototyping works well with the 3D printing. I think we should move this one a little bit, okay.
Pull it towards you. No, pull that side with you. Just, no. It's like that, yeah.
You want me to start from the beginning?
No.
Rapid prototyping, you know, but here we did things, whatever we have there, we try to come up with a project and we ask them to work on this one. Though this is using a sensor, they have to come up with a quick product. So sometimes they use my picture to make things kind of fun. So you can see these teams, they design something using sensors. Actually, this like a sound type thing. Sometimes normally they use all kind of IoT sensors for different final project. I don't have time to talk about some of their final project. Actually, they came up with very nice idea. Suppose you're going to a very big library. You want to locate a seat, right? Like, you can simply put sensors everywhere. Based on that one, you can see where the free seat is there. Same thing for the parking lot. Some parking lots are huge. You want to locate a space. You just put simple sensors are very cheap nowadays.
$5.
Somehow you integrate with your cell phone. So you can see, okay, in this parking lot, at this parking lot, these 2 spots are free. Then you go to Google Map, click on that one, it'll take you to that particular spot. So these are things they try to come up with, integrate. So these are things. Now the question is, what is this one to do with STEM? STEM mainly we talk about elementary school, high school, middle school, things like that. But the thing is, I'm proposing we can make this minor scale, micro scale, things like this for high school project or middle school kids. You don't need to go to Silicon Valley, you can go to the same city. There are so many places there, so many companies there, so many people, they can come and give presentations. There are camps there, you can put them, take them to a camp for 1 week or weekend, things like that. So now at this point, and keep moving here, we didn't stop here. Now you see, tell me, what do you see in this picture? Intel sign? Yes. Do you see me?
Yes.
That's me. Any other? Do you see a lot of birds there? Can you see? Intel. They are one of the big companies. What is it?
Birds?
Yeah.
White birds. Right?
White birds, he is right. But look at this one. The white birds changed now. Look at this one. Those are not white birds. They are using mini fans there to produce energy. They are using solar panels to the zero energy building. So these are the things I am trying to ask my student to work on. Use sensors, innovation techniques, and come up with projects. You can't invent something within a semester or within a year or within 5 weeks, but you can try to innovate something or come up with an idea for innovation. So this is now I am getting into real projects.
You want some water?
I have coffee, okay. That's fine. These are real projects we did. The idea of this one here, student has to come up with a proposal. They have to come up with an idea. They have to model things using AutoCAD, SolidWorks. Then they have to come up with a prototype. Not only prototype, they have to prove the concept. Means they have to make a product using whatever sources we have, whether 3D printed material or sensors or using makerspace, using wood pieces and things like that. They have to come up with something. Not only that, they have to say, okay, this is the proposal, this is the objective, I can produce this much. Then they have to write a paper. It's not, I didn't ask them to give a presentation. They have to give a presentation, but they have to write a journal paper. So these are papers actually we published, right? Some of them we published at ASW, called American Society for Engineering Education, National Conference, Regional Conference. How to take advantage of existing system like Intel. They are using fans, solar panels. Like this one, you go to gym, we do a lot of exercise. Right? We waste energy. Can we take advantage of those energy? We sit and type on the keyboard all the time. Can we create a little using this piece of electric material? But each time when you type, can we generate a little electricity and can we pass it to something? That's not practically easy thing. We are trying to introduce that to our student. They will come up with a creative thing one day. Are you guys with me for that part? It is not that we can solve the problem. See, you can see physically they made this one. When they type, you can map this one. That's the reason they have to learn programming. They have to learn this IoT. They have to learn how to interact with machines. They have to learn how to make things, and they have to come up with the final out. These are things, a portable charger. They use different technique to make a portable charger. That means you put that in the pocket, you walk, right? If you need to recharge your phone, you have a charger there. Of course, there are so many models already there, but you always innovate. That's what Steve Jobs did, right? Innovation. Just come to the next level. The innovation based on customer need. That's what the title we call customer-driven technical innovation. You can innovate things. Sometimes it has no use. So these are, I'm talking about the pocket charger. Can you see? The student designed this one. Final product is very simple. It'll costly at the beginning. Once a company takes this one, they can make this one into $2-3 or even $1. So things like that. But they have to, and I think probably, maybe I don't, see this is, they play drum all the time, right? That means vibrational energy. Can you take advantage of that one? Only thing, we ask them to prove the concept. Yes, we can use whatever material there. They did some calculated, whatever systematic study they are using a scale here, they release this one from certain distance to strike this one. This way they can see what kind of changes. And this is another one we published last time at the ASW in this last June, a mini generator. Mini generator, simply at home you can charge your phone, you can do things. In long run you can pass it to the grid. If everybody started using, these are fresh water, it's a good water, right? So simply the water is still coming. Only thing you are adding something to produce something.
The turbine.
Yeah, it's a micro scale. That's not the only one. It's the innovation is not invention. I am not inventing term. I am innovating this one, how to store this one and pass it to the grid and things like that. I am not getting into that part, invention side. That's not possible. So I think I can keep moving. I have another big presentation too. So these all,
1 minute.
okay, these all some of the projects we did. Actually, this is somebody did some in medical side. So there are different type of things. Okay, I want to skip this one. This, we are taking advantage of this one to make money. That's it, simple as that. To save money, let's put it that way. This actually, we designed this one. They designed actually, it's in a very short time. Right? Idea is to charge the phone and things like that. This is more technical detail using 3D printer and AutoCAD and SolidWorks, how things work inside. Of course, this is the proof of concept. They have to prove this one. You can generate and you can store, those are things they need to do. It's not just giving a theoretical idea. At this point, we have published so many papers. These are actual peer-reviewed conferences, right? You can see these are the papers, right? So, and these are, I'm showing you some sample, the paper, whatever information and details. So these are some posters they presented at conferences. You can see ASW, that's called American Society for Engineering Education, with almost 10,000, 12,000 members. So we have regional conferences too. And student even got the first place for their work.
Nice.
Right. They publish things. This is actually 2000 April at Niagara Falls. we send almost, I said personally, because that's a local, within USA we can send people easily. Greece is not easy. So these are conference papers and things like that. Right? So at this point, I don't want to get into why did I move to innovation side. There's a reason for that. Right? I'll stop at this point. I can answer questions later. Actually, I was thinking of giving a talk in different topic. That is, the title is Global Challenges and the Future Jobs via Reskill and Upskill. Your reskill means, things are going to change very soon. It's changing.
Good.
But
Nice.
just
It
nice
was
listening.
more into it.
You want me to go further?
And no, you can go have a discussion.